visibility within the black box and what that computation that happens in the learning algorithms mean to humans. One very simple reason is the following. Whenever a deep learning algorithm, machine learning algorithm comes out with prediction or does the classification, um, uh, unless that is explained in terms of the in the form that is understandable by the expert, the user, it is not going to give you the visibility. So when a clinical person, medical practitioner, is given a recommendation or a suggestion or a possible decision they can make based on data analysis using deep learning, unless it is framed in the context of the medical practice and the protocols, it doesn't mean anything. How do you make the uh, deep learning algorithm understand the way a medical practitioner thinks? You have to have the user model, you have to have the knowledge of the that particular protocol incorporate into the learning to make it meaningful. So that is the fundamental. If there's one takeaway I'd like to share with you, is that one. And like any major activities, this is a team effort, and especially Manas and Kaushik and whole variety of people who work with me on knowledge infused learning are the members. There's a one slide introduction to the AI Institute at University of South Carolina. In the center are a whole bunch of AI centric research that AI Institute is doing, and on the outer side you can see that we are very much into translational research. So practically everything we do have applications working with the domain expert, real world data and such, that allows us to make larger impact. And you can see a whole bunch of area that we work with. We already have collaboration with majority of the colleges on the campus and many outside. Outline is to, and in fact, given that um, I only have about 30 minutes to talk, I'm going to have to kind of skim through many of those things. I will try to, share the salient parts of it. Knowledge graphs, I don't think that there is need to introduce here. Ontology, knowledge graph, they are cousins and they're making huge impact. This is a pattern that we filed in year 2000, well before the famous 2001 paper on semantic web, and this was awarded in 2001. And you can see on the right hand side what looks like a knowledge graph. Another word we had used was world model, because the and ontology both were used in the patent. The reason is that the world was not quite ready for ontology. The commercial world was not quite ready for that, so we used the world model. Now that has starting to become popular also. But at the representatives level, it's really nothing different, not at all different from knowledge graphs. And so here we developed knowledge graph driven techniques for browsing, searching, profiling, personalization, advertisement, and such. And there is a link to an article that shows you what we did then and what I saw through 2013 and 14 when Google came out with semantic search, and how we had already, the relationships of between the two efforts and how things have changed, if at all. Okay, what happened? Oh, for some reason it kicked on. All right. There is a proliferation of knowledge bases, knowledge graphs, and some of them are general purpose, and and others are specific. Just in one domain of healthcare, I listed some of those that are either the knowledge graph or source for knowledge graph. In enterprises, knowledge graphs are so widely used. One of my students last 2019 went to the research group in Amazon. He called back in a couple of months and he said, Dr. Sheth, I can't find a single project around me that is not using knowledge graph. And so this is there is a huge growth of knowledge graph. I'm a bit surprised that this was not used before the deep learning became popular, but now this has become very symbiotic. I'm reminded of the uh, panel at the AI Debate 2, recently organized by Montreal AI, where they talked about role of knowledge in the AI. Here I'm showing you empathy is a knowledge graph that my team developed for disaster. On the right is a knowledge graph that this is from my third company I founded, which is on health care related area, and this is a deep knowledge graph related to healthcare. Um, and this is a company that I'm working with now called Imbibe, and a knowledge graph for education. So these are for real. This is a paper that we recently did with Hemant and Valerie, and this is you know putting out the fact that knowledge is not only about capturing the domain, but at the end of the day, AI systems are there to serve human needs, and humans are complex being, and with that, with human we have social norms, we have individual priorities, and our own culture. Each of us have our own cultural leaning. We have common sense knowledge, and we have so domain specific knowledge that we usually focus on is only one aspect of it. And I still focus mostly today on not domain specific knowledge, but there is a whole body of work that needs to be done for the agents and for the AI systems to really understand the master. The master is the human that they are supposed to serve. So there is a theme that I had talked about called computing for human experience, not that computing, not the AI that replaces human. That has been my interest. Um, at the end, uh, I love to do interdisciplinary work, and I love to learn from other disciplines, particularly cognitive science, neuroscience, and behavioral economics. And in cognitive science, this concept of top brain and bottom brain has been uh, well discussed. And in the AI, uh, the first generation of AI looked at symbolic, and also called symbolic AI, focused on reasoning, and the arrow on the bottom is about statistical AI. And I think, at least in my way of thinking, knowledge and experience are the glue. They have to come together. We all have heard about neurosymbolic computing, and there are many ways to it, but I feel that the neurosymbolic computing achieved through use of knowledge to intermediate and connect the patterns and perception with cognition and high level abstractions is critical. So now there are many, just in the area of NLP and NLU, there are many reasons for using knowledge graph. They're listed here. And today I will just touch upon a couple of them that are in this gray, in the brown, color. And in the NLP NLU, for example, I'm showing you a paragraph in a news article, and as you think about trying to understand this paragraph, you're going to find that a bunch of knowledge from diverse sources will become important. So the DBpedia, for example, can help you get the categories, subcategories, and properties in DBpedia. Uh, but then, and then you can get to the entities like individuals presenting, or men are showing influenza, or so phrases like that. But you really want to understand it. So there is natural language processing, but natural language understanding. And if you want to get to that you part, understanding part, you can't do without having a knowledge to support you, acting as a trellis on which you can hang your ideas. So influencer like illness on the left hand side is not recognized, but influencer like illness is concept that is well recognized, on the right hand side, and that is very important. There is a specific meaning of high proportion that is also important. And then once you start incorporating SNOMED city and other medical knowledge, you are going to get more insight and more understanding of more terms and more specific understanding of those terms. And when you are all done, then you'll be able to get a whole bunch of entities and relationships which I did not talk about, that will help you, annotate the data, and hence later on support semantic search and better ways of finding the data, and so on and so forth. And in the deep learning, we are going with this more and more, you know, getting out more and more subtle semantics, subtle rather patterns from the data. And after GPT-3 with 175 billion, now we are talking about trillion parameters, that Google has worked on. And what is happening here is, it's first of all incremental, but fundamentally, it still is not getting you to uh, things that are very, very important for real applications. And for me, they are ability, dependability, veracity, reliability, verifiability of what you're finding by using the system, contextualization, abstraction, and personalization. These are the key features that I can think of for the kind of applications I want to develop. This, deep learning is by itself not helping me out enough, and so I have to find a way to, merge, to combine deep learning with knowledge graph, to make understanding more detail, more, and support those kind of features that I talked about. Here, there are good techniques to, for example, take vast amount of data and then create those clusters. But then by incorporating into those clusters specific, knowledge about the domain. In this particular case, I'm talking about opioid drug knowledge graph. I've given the citation. You are able to see within that with specific labels that are meaningful through their association with other labels that you can find in a knowledge graph. A long time ago, I talked about relationship at the heart of semantic web. So this is not just entity, but relationships that are also very important. The other thing is that there are, the systems that we build, the AI systems they come with a lot of bias. And in particularly the top three are the ones that I think are the ones that I can address better once I incorporate knowledge in conjunction with the deep learning algorithms. And it's very hard to deal with this bias if I don't, have the knowledge as my partner. Um, Now let's look at semantics, association of meaning with data, and other things. This is a definition I used long time ago, and many people have used it. Um, Take a simple example of question answering, and question is, does this person have addiction? Answer is yes, using sequence to sequence model, and that happens to be correct. But you take this particular text now, and you ask, does this person suffer from depression? While the machine will give you yes, in reality it is not, the answer is no. And what you need to be able to do is to, reason, as I've shown here, why. In manic episode is a characteristic of anxiety and not depression, and the person talks about manic episodes, and so on and so forth. These kind of things are necessary to be able to correctly answer this question, which your vanilla deep learning algorithm can't do. In some cases, you have to do multi-hop reasoning. What can cause forest fire, and from those answers, possible answers, you say static elasticity, because you can reason, as I've talked about there. Um, Adding knowledge to data intensive learning, provides you both performance and interpretability and explainability. Now, this is already being done to some level, but not so overtly. So, what is happening is that in some very, very spectacular effort like AlphaGo, there is knowledge, game related knowledge that is incorporated, in terms of what constitute good steps. And then you can using Monte Carlo trees, so you can create an explanation of why those steps worked in a game. Uh, but this is still not, this is still a baby step, and the kind of knowledge infused incorporate here is very, very basic, and it's okay, it works for a game, but in the real world for many other things, the knowledge continues to change. So you need to keep in mind, it's kind of a next step beyond what AlphaGo was. You can find in AlphaFold another major success story. But in this particular case, taking the information from protein DB provides for, so leveraging knowledge from protein data bank enabled this system to perform very well. But still additional steps for knowledge infusion required, because why this is the best structure for a particular purpose. So this one comes out with a varied structure that follows physics and chemistry. But why is it a good, functionally good result? uh, for example, if I'm applying this to drug discovery, then a valid drug molecule is the first step. But then saying we whether that drug molecule, a candidate for drug, has the right solubility or right toxicity profile are the functional thing, and the relevant knowledge have to be brought in to find a molecule that better meets the need for for future work that the scientists want in drug design. So for protein design, drug design, we've been able to reach a stage where we can say physically, chemically, this is the valid structure, and we can do that very efficiently from a vast space. But from there, to get something meaningful and really useful for application, we still need to do more. And I think that for that, what you need to have is knowledge from outside. Here is an example of a contextualization, personalization. You ask Alexa, how is the weather today? So the weather is this kind of thing. Enjoy your play. But if you know that the patient is is an asthma patient and has ragweed pollen, then the system can be a lot smarter and find out what is the pollen today. This is available through web service, it's not that hard. And then it'll reason to say, yeah, weather is good, but you could have you have this phenotype, you have this potential system that has been shown to occur. Then make sure that you take your rescue medication with you. Then let's see, here's a very another interesting example. On the right hand side, you see uh, the speed on a road network through sensor data, road sensor network. And on left hand side, you see the tweets that are coming in, and I want to be able to connect these two modalities so that I can use Twitter to explain why the traffic might be slow for this particular time. And if I want to connect these two different modality at a pixel level, or at a signal level or statistical level, there's hardly anything I can do. Yeah, I can create a vector from both of them and merge them. That will not give me anything interesting. I need to take it to the higher level of abstraction. In this case, I have an understanding that Golden Highway at Viking, robots in Devland is a location, and around that we have there's overturned truck, and now I can use as an explanation. But connecting this kind of multimodality is again, I use deep machine learning or deep learning, but without these things is impossible. Here it shows a pipeline of knowledge graph in NLP that uses knowledge graph, and some of our work along each of the steps of pipeline. The thing that is of huge interest to us is really combine symbolic AI with statistical AI, and see the benefit of that. So in this knowledge infused learning, Um, there are many challenges in deep learning that are outlined on the left hand side, and I've given some reasons on the right hand side of why how we can address these. In interest of time, in interest of time, I'm kind of skipping or going faster. Um, Let me show you something interesting here. I'll make this comment. One of the area of what we address is radicalization on social media. The interesting thing is that um, uh, if you try to understand the complex area of radicalization, there are a lot of human dynamics and how a jihadi is convincing a disenchanted youth in Western world to join them is pretty complex. So just doing it from analysis of data is useless. What we did was to take empirical work by a political scientist who said the critical factors are religion, ideology, and hate. And then what we did is to create the pipeline for this deep learning pipeline that analyze each of these things with respect to the corresponding domain knowledge for religion that came from Hadith and Quran. And it allowed us to distinguish between jihad used in the normal positive religious mode versus jihad used by the jihadis, and then understand the nuances of those. Because we had the knowledge for each of the domain, we could do that. Otherwise it's pretty much impossible. We come up with a kind of a taxonomy of the different ways to bring in knowledge into deep learning. There's a shallow learning, there's semi-deep learning, there is deep learning. The example previous I gave about radicalization, it was the example of semi-deep learning, because it took segments of the things and infused at one step in the whole process. Um, I have some models at a very high level to introduce you. The shallow infusion, which is embedding basically kind of things. So knowledge and data embeddings are kind of combined. Semi-deep uses attention to bring in the knowledge at one layer, and deep learning brings attention at different layers and infuses knowledge at different levels of abstraction. So it is a multi-layer kind of things. And there is paper that is available that gives you a lot of examples. Here is a simple visualizations where on the left hand side you see the the vector based representation of word in tweet using embedding. But then if you use knowledge graph or some knowledge, you are able to bring damaged infrastructure or affected population closer, and that is where that will be more meaningful insight that you can get from data compared to what you have on the left hand side. Here in this case, being able to more appropriately characterize these different clusters that you have, and essentially what I can find in EMR on the left and what I can find in social media on the right, and combining them is something that you can do using knowledge graph. This one is an example where you use a knowledge graph. One of the most important activity in automated vehicles is scene similarity detection. So here we show that we can collect the kind of aggregate the scenes that are similar far better by using knowledge graph than without. The semi-deep infusion. This is an interesting example. One example I would like to discuss. So here on the left hand side, you see data coming from different Reddits. Bipolar disorder Reddit is the first one. That data came from that. The third one is depression Reddit. And on the top, you see different concept from the medical literature that is used to understand, to gain clinical understanding of mental health. It's called DSM-5, and that helps me define, let's say, bipolar disorder or suicide ideation. These are the terms on the top here, the concepts on the top here. You see, SBI and SAD. So these are various conditions related to mental health, and you can see various texts here, but understanding this text and really making relevant inferences from this text that are for clinical decision making is extremely hard. So what we are able to show is that in understanding that text, we had to resort to use of multiple different knowledge sources. There is a suicide risk severity lexicon. There is a DSM-5 lexicon that I mentioned earlier. There is a drug abuse ontology that we have discussed. Mental health and addiction often go together. And then, of course, there's Snowbed City kind of thing, which has treatment information. So different kinds of information we want to extract require different kinds of knowledge. And what we were able to do is to take this the post and machine learning, but infuse the knowledge as you see on the bottom, and then we are able to create better label. And this essentially, when you do what you're doing is to create a kind of metrics. On the left hand side is the Reddit content, the content and the words from Reddit, uh, content from different Reddits. On the left, on the bottom, you see variety of medical conditions described in the DSM. On the right, it is they are all listed there, and then you are creating this matrix, which is gaining deeper semantics from the data. And then what happens is that on the left hand side is your standard model, and the right hand side you have the model that comes by use of the knowledge graph. And when you combine the two, you are able to do much better. For example, there is a post here in bipolar subreddit on the top, but it is not about a bipolar disorder. It is actually about depressive order. And it is about, we are able to make these kind of distinctions because we are using knowledge in the kind of way I described. So these are the major kind of things. Here is a very interesting graph. You on the left hand side, the false alarm rate is 0.3 with just use of lexical and syntactic feature. Then you add more features, TF-ID, WAV. Then you add contextual features. Then you add DSM-5. You can see big jump from 0.13 to 0.04. Then you add drug abuse ontology, is somewhat improvement, already is very good. And then you add slang terms and other things and still do a little bit more improvement. So you can see how you can improve that. I do not think that this kind of improvement will just come by just throwing more data at the problem. Similarly, we have some work on combining this knowledge infusion into doing knowledge infusion into reinforcement learning. So in the last part of what I will talk about here is that explainability is very important. It plays role in many of the important themes in explainable AI. I just going to give you one example that using model here is mental health related. Is this mental health related? The answer is yes. Then which mental health condition? It predicts depression, which is wrong. The correct answer is obsessive compulsive disorder. So this is our baseline. And then what we did was, here you see an infusion of that correlation matrix that I showed, right? So using the DSM-5 knowledge graph and correlation matrix, we were able to then enhance the learning method, and we predicted obsessive compulsive disorder, which is true. And one of the things that's happening here is that you are able to incorporate, the system is able to understand that chaos in my relationship, right? And that is often used in this kind of medical, mental health related understanding, or get drunk, or is in, that takes you to addiction and drug abuse, and then there's intrusive thought. So you are able to understand these kind of concepts, and that this one is related to symptom, and this one is related to treatment, and those kind of things, that association of the meaning with the content is what leads you. By the way, the other important thing is that you are able to then construct your explanation in the context of these kind of concepts that are in the knowledge graph. Without that, you only have characters and words, and there's statistics. How can you construct a good explanation, right? So that is a fundamental reason why knowledge is critical in creating explanations for user human consumption. and humans are going to understand those concepts very well. So in that, but in the street, here I have a concept of health related behavior. I have a concept related to LGBTQ, a concept of drinking, and I can bring that in making these text understandable, and I can explain that it is because of drinking that this thing is this is the outcome and not the other one. There is more here. We did open-ended interview between physician and patients in mental health, and also use these knowledge-infused techniques to be able to summarize what is a 56 sentence conversation into 7-sentence conversation. And then there is one more interesting example. But this one is that knowledge is dynamic, and we need to have the our human knowledge continues to change as we learn more things. The same thing has to happen with the machine. So uh, anyway, this one is about COVID and lockdown and decision making about lockdown. In the interest of time, I'm going to pass. So here are some of the sub areas that our group works on, and there are many other areas that we are exploring that generally involves knowledge infused learning in robotics, cognitive science, self-driving cars, personal assistant. That's one of the big areas for us. The point here is that basically, um, in the past we have survived with growing amount of human labeling effort, and through did feature engineering and whether use deep learning to do that. But now we are trying to take that towards this area where with knowledge infused learning you have to do much less of this human involvement. You can use the existing knowledge and so on and so forth. Okay, with that I will end so that there is at least 5 minutes left, I